Welcome to Mini Maths at Virtual School Victoria. Today's theme is the different types of numbers in our number system. Think about all the different types of numbers that we know. Here are some examples. We have squares and cubes and factors and primes and cardinal numbers and decimal numbers and compound numbers. Definite sort of numbers, so there's quite a huge list of different types of numbers. A number system starts with the counting numbers or the natural numbers, and they are always whole numbers and they count quantities, so we can have 3 things or 4 things. Our whole numbers, our natural numbers, can be broken up into odd and even, and you can have odds and evens even in the negative numbers, the ones that are less than 0. How do we identify an odd or an even number? An even number is one that we can evenly divide by 2 and there are no remainders. So I can put 8 into 2 groups of 4, no leftovers, and it is an even number. If you take a number like 5, there is no way I can make this even groups, because whatever I do, I will always have 1 left over. So that's why we call it odd. There's the odd one out. Now, the interesting thing about odd and even numbers are their properties. So if you add an odd and an odd, the answer will be an even. If you add an even and an even number, the answer will be even. But if you add an odd and an even number, the answer is odd. You can learn more about these properties of odd and even numbers at Maths is Fun. There's a lot more information of what happens when you multiply or add or subtract odd and even numbers. Now, there are composite numbers. And a composite number is one that is made up when you multiply 2 numbers together, except for numbers with 1. So I think of composite numbers that they're the answer to a multiplication table. So let's look at this chart and let's find the composite numbers. 1 cannot be made up by multiplying 2 numbers, nor can 2. And 3, I think, is the same. You can't really make groups of 2, but if you look at 4, that's a composite, and 6 can be 2 3s, 2 4s, 3 3s, 2 5s, 2 6s or 3 4s, 2 7s, 3 5s, 2 8s or 4 4s, 3 6s or 2 9s, 4 5s or 2 10s, 3 7s, 2 11s, 2 12s, 3 8s, 4 6s, and 5 5s. There are our composite numbers that are made when we multiply 2 numbers together. Anything that is not a composite number is a prime number. And a prime number cannot be made by multiplying 2 other whole numbers together except by 1, but you still get the same number. Let's have a quick look at the numbers that are prime. They're the numbers that can only be divided by 1 and by itself, and you can't multiply 2 different whole numbers and get it. So let's start at the chart and have a look. All right, we saw some of these. No answer to the tables. Okay, let's see if we can do this quickly. So these are prime numbers, and prime numbers are very important in our mathematical system. You can come back to this and see if you can find other prime numbers in that number chart. And of course, when you don't have whole numbers, you have rational numbers or fractions. So it's a ratio. So 1.5 is a rational number because for Every 3 we have 2, and that would be left over. There would be 1.5. We have decimals, and they're less than 1 or between 2 whole numbers on a number line. They're expressed in tenths and hundredths, and they're very interesting numbers on their own. And of course, we have negative numbers. Negative numbers go below 0, and it's what we don't have. If you're looking at square numbers, they're numbers that can be organised in a square. So if we look at this, the next square number is 4 squared, which is the same as 4 times 4, which will be, oh, can I do this? Which will be 16. What do you think the next square number will be? So it'll be 5 times 5. I've got 5 rows and 5 columns. And that would be 25. And the square number has a really good pattern. And when we write square numbers, basically this is that we multiply 4 by itself, 4 times 4. And they are square numbers because we can organise them in columns that are 5 and rows that are 5. Rows that are 7 and columns that are 7 and 10. So these are all square numbers: 5 times 5, 7 times 7, and 10 times 10. I wonder if you can calculate mentally the answers to these square number problems, and you will see a pattern. And Fibonacci numbers. Can you work out the pattern for the Fibonacci numbers? How these work is you start with 1 and you add those 2 and you get 2. Then you add those 2 and you get 3. Then you add those 2 and you get 5. Then we get 3 and 5 will give us 8. 5 and 8 will give us 13. 8 and 13 will give us 21. 21 and 13 will give us 34. 34 and 21 will give us 55. And you can see we're getting quite large here, and that will give us 89. And here is an example of a Fibonacci pattern. There's some good stuff on the internet for you to find out. And finally, there are so many numbers that we didn't cover. For example, integers and factors and triangular numbers and cubes. And we could have done rational numbers in a little bit more detail. Now, that is only a small portion of all the numbers that we have in our number system. It would be wonderful if you went and investigated more. Thank you.